Good day, family. I believe today too we are coping gracefully. By the grace of God, I believe you are also good. I'm also doing well. Wow, today too I welcome you back to my channel. This is Ben's channel, and I'm here to always be of guide. I'll guide you through your mathematics journey, and I'll make sure that whatever topic that's supposed to be treated in mathematics, I will be in charge of that responsibility, and I'm here today to help you understand some concepts in mathematics, specifically the algebra, as you can see over here. So I have algebra. Today we are diving into how to simplify algebraic expressions. How to simplify algebraic expressions. So I will encourage you to stay tuned. You subscribe to my channel, and please, if you find this video helpful, kindly share it among your friends so that your colleagues out there too will also benefit as you are also benefiting. Don't try to be on your own or selfish. Please, we created this channel purposely to help students to excel in their academics. So I'm here to encourage each and everyone to subscribe and stay tuned always. And always, I promise you that we will give you the best version of mathematics always. Quickly, we don't want to waste my time. I am your tutor, Richard Oben, and let's quickly dive into how to simplify algebraic expressions. So as we can see, we have some sample questions here, and over here, all these terms that we have here, we call them algebraic expressions. Now they are algebraic expression because, for one, it is an instance where variables and numbers come into play. I would mean numbers and variables come into play. That makes it what? An algebraic expression. Two, we don't have any equal sign within this. So if you look at question number one, we have 6xy plus 3y minus xy plus 2y. So you realize that there is no equal sign in it. That makes it what? An algebraic expression. There is no inequality sign in it. So if I say equal sign, I am referring to this. There is nothing like that in there. We don't have any equal sign. We don't have any inequality sign. We don't have anything like that. We don't have less than sign. We don't have less than or equal to. We don't have greater than. We don't have greater than or equal to. Nothing like that in it. It's in it. So here we call it algebraic expression. There are variables. There are numbers coming into play. That makes it what? Algebra, and it makes it an expression as well. Very good. So let's see how to simplify it. Now, the idea of simplification in terms of algebra comes into play when we are adding, subtracting, multiplying, and dividing. That is what we meant by what? Simplifying algebraic expression. But for now, right now, today, we are going to dive into how to add and subtract algebraic terms or algebraic expressions. Very good. So stay tuned and let's see the best version of mathematics today. Now, before we will tackle the questions head on, I would like you to understand certain things when it comes to algebraic expression, how to simplify algebraic expression through addition and subtraction. You have to understand certain things before you'll be able to solve these questions. And these terms, I will expose it to you one after the other. I would mean. Very good. So, under algebra, before you'll be able to add and subtract algebraic terms, okay, now there are certain key words that you need to understand. So these key words include one. I am starting with what we call terms. I said what? Terms. Very good. So I will start with the first one where I will term it as terms. So take note of this thing that I have here. When we say terms in algebra, we are referring to the constituents within the expression. I would mean Now, how will you be able to identify the number of terms that an expression is having? So here we are using the operational sign, addition and subtraction. Okay, we are using these two signs to do that. So let's take it for instance, a yardstick here. If I have 2 minus x, the question is, how many terms do I have here? Okay, now have it in mind that anytime that there is one of this operational sign in between two constituents, okay, it makes it what? Two terms. So here I have one constituent and I have another. Are you getting me? So this one become one term, another term. So here within this expression, I am having what? Two terms. I believe you are following. Very good. In the same manner, if I have 2x, if I have 2x here, okay, we looked at this, we said this one has what? Two terms. Now if we look at this 2x, this one becomes what? One term. Why? Because we don't have any of these operational signs separating the 2 and then the x. So take note, this is different from what? This. Please take note. So this one is what? One term, and this one is what? Two terms. Now another one that we have to take note of. If I have 3, let's say x plus, let me use 2 plus 4y. Okay, so I have 3x plus 2 plus 4y. Okay, so over here, let's count the number of terms here. I have 1 term, 2 terms, and 3 terms. So I have term 1, term 2, and term what? 3. Are you getting me? We said we check the number of times looking at the operational sign, addition and subtraction. Addition and subtraction determines the number of terms that an expression is what? Having. I believe you are following. Very good. The last one that I will dive into is, let's say we have 4 minus x plus 2m minus let me say 1. So this one also, let's check the number of terms. I have term 1, term 2, term 3, and term 4, because the subtraction is separating the 4 and then the x, addition is separating the 2m and then the x, and here too the negative sign is, or minus sign is separating the 2m and then the 1. That makes it what? How many terms? 1, 2, 3, 4. I believe you understand. Very good. So here, in conclusion, we will say that the number of terms in an algebraic expression is determined by the operational sign, addition and subtraction. I believe it is clear. Very good. So let's continue with the next trick, or the next thing that we need to understand when it comes to algebraic expression. We dive into what we call like terms. I said we dive into what we call what? Like terms. Very good. So with like terms also, now I told you that the terms are being separated by what? The addition and the subtraction sign. Are you getting me? The operational sign, addition and subtraction. Are you with me? Very good. So here, remember there are some terms that are what? Like, and there are some terms that are unlike. So here, like terms, we are referring to terms which are identical in nature. Very good. So I'm going to explain the like terms one after the other so that you also understand it. Now let's take this as an example. Assuming we have an expression containing two terms here. I have 8 minus 4, let's say x. In algebra, let's ask ourselves that this expression containing two terms, are these terms like terms? Are these terms like terms? Remember, I told you that like terms are terms in an expression which are of the same identity. So let's check whether these two terms are of the same identity. Now, the identity here, we are checking the variable that is attached to the number. So here I have variable x that is attached to the number 4, making it what? 4x. If I come here, this is 8. We don't have any variable x attached to it. So the 8 stands on its own. I believe you are following. The 8 stands on its own. The same manner when we come here, we have 4x. Are you getting me? So this is to tell us that because here there is no x here and here there's x, meaning this and this are not what? Like terms. They are not like terms. Are you getting me? Very good. So these are not like terms. So not like terms. I believe you are following. Very good. Now let's take the next example, expression involving, three terms. Okay, very good. So we have something like 2, let's say y minus 6, let me use xy plus let's say 4y. So over here we have 2y minus 6xy plus what? 4y. So let's identify the like terms in there. Now if you look at here, the first term 2y, 2 has y attached to it, the 6 has what? Xy, and this one has what? Y attached, the 4 has y attached to it. So over here, looking at the like terms, we are referring to terms with the same identity. If I take the 2 has y, variable y attached to it. The 4 too has variable y attached to it. So here I will consider 4y and 2y as what? Like terms. So I will say that 2y and 4y are what? Are like terms. I believe you are following me. Yes. So the 2y and then the 4y are like terms because if you look at the 2, there's y attached to it, a variable y. The same, and if you look at the 4, there's a variable y attached to it. Are you getting me? So therefore, if I'm to solve this, if I'm to simplify, this, I can do what we call grouping of like terms, meaning I'll group the like or the terms with the same identity aside and I will simplify that. So here grouping is, I'm going to get 2y, this will come here making it what? 4y minus 6xy. Very good. So here I can add the 2y and then the 4y. So adding it, I will just check the coefficient. So the coefficient of y here is 2, the coefficient of y here is 4. So I can easily add. So I'm going to get 2 plus 4, which is giving me what? 6. So here I'm going to get what? 6y minus 6xy. Here I cannot subtract the 6 from the 6y because here is 6y, here is 6xy. The 6 here has xy attached to it and here is only y. So I will leave only this as my answer. So this then becomes my answer. I believe it is clear. Very good. So this is what we call like terms. And then therefore we can conclude that if these two are not like terms, they are what? Unlike terms. So have it in mind that in algebra, like terms can be added and subtracted, but unlike terms can neither be added nor subtracted. Are you with me? Very good. So now let's continue with life. Now that you understand, we are going to take the questions one after the other and solve it. So let me take question number 1, but before that, let me write down my solution. And take my question number 1, which is 6xy plus 3y minus xy plus 2y. Alright, now before I'll be able to solve this, we need to understand what we call like terms. That is why I pre-explained it. So now we are going to do what? Grouping of like terms. So remember, I told you that in algebra, anytime that a variable stands on its own, meaning there is a coefficient of what? A unit number, which is 1. Are you getting me? So here you can see that we don't have any number there. But so far as the variable stands on its own, meaning there is a unit coefficient, which is what? 1. So there's 1 here. Have it in mind. Very good. There's always 1 when the variable has no coefficient. So if I have x standing on its own, meaning there's a coefficient of 1. But we don't normally write 1x because 1x is the same as what? X. So please take note. Right. So we are going to do what we call grouping of what? like terms. Fantastic. So let's come here. Before that, let's check the number of times that this expression is having. We have one term, two terms, three terms, and four. So we are grouping like terms. So the first one I have 6xy. The like term is this, which is negative 1xy. Then I'll check if there's another like term there. No. So I'll continue with this. So plus 3y, then plus 2y. Then after I'll move on with like. Now 6xy and negative 1xy are like terms. So I'm going to deal with that head on. The coefficient of xy here is 6. The coefficient here is minus 1. So I'm going to get what? 5. So my answer becomes 5xy. Are you following? Very good. So if I should continue with the process, I now have 3y and then 2y. So the coefficient of this is 3 and the coefficient of this is plus 2. So I'm going to get what? 5. So here becomes plus 5y. Are you with me? So this then becomes our final answer. We are through with that. So that then becomes our final answer. Algebraically, we cannot add a 5 here to this. No. That we are going to get 10. No. Why? Because this one has xy attached to it. This one has only y attached to it. So algebraically, these two are not like them. So therefore, this becomes our answer. I believe it is clear. Let's dive into question number 2. So question number 2, we have 3x plus 4y plus 2x minus 3y minus y. Okay, where I told you that any time that a variable stands on its own or variable stands on their own, there is a coefficient of what? A unit number, which is 1. So let me introduce 1 here so that you will not get confused. Now let's go with like terms. If I should take this 3x, the like term is this, so plus 2x, because here is having x attached to it, here too is having x attached to that. I get it. Let's see if we have any other term with x attached to it. No. So I'll continue with the next one, which is plus 4y minus 3y and minus 1y. Very good. So this, we add the coefficient. So 3 plus 2, well, we are getting what? 5. So here becomes 5x. Then after we dive here. So this you can decide to do it once, or you can do it one after the other. Very good. So here we have plus. When we subtract 4 minus 3, we are going to get what? 1. So here becomes 1y minus 1y. Okay, we solve this one first, or you can decide to do it once. So 4 minus 3, we are getting 1. Okay, then this one came downwards here. So now we are having 5x. Okay, we are having 5x. We are having 5x. 1 minus 1, we are going to get 0. But have it in mind that algebraically, we don't have this 0y. No, it does not exist. Okay, we don't have a number 0 and a variable. No, we don't normally write that. So if this one becomes 0, then it means it is what? Gone. It is gone. So I'll leave this as my answer. Please never add 0y. No, the answer becomes this as it is. I believe it is clear. Very good. So if your understanding is clear, we dive into I will leave question number 3 for you to try your hands on it. You share your answer with me in the comment section, then we discuss that. I believe you'll be able to do it quickly. Let's dive into question number 4. So question number 4, I have a plus 3ab plus 67a. Then I have minus 2ab, and the last one, which is minus 1. Very good. So here to our group like terms that we move on with by. So I have, remember Remember, it is a variable standing on its own, so the coefficient is what? 1. So here becomes 1a there. The like term is this, which is plus 67a. Then do I have any other term there? No. So I'll continue from here, plus 3ab, then minus 2ab minus 1. So they are like terms. So I'll add 1 plus 67, and I'm going to get what? 68. So I'll get here 68a. Let me write it well. Then I'll come here to 3ab minus 2ab. So 3 minus 2. I'm going to get what? 1. So here becomes plus ab, or plus 1ab. It is also correct. I get me. Either write 1ab or ab, still the same thing. Now we come here minus what? 1. Okay, so our final answer plus ab minus 1. Remember, we cannot subtract this from any of these, okay, because this one is a constant. It stands on its own. Are we okay? Very good. So this one then becomes our answer, 68a plus ab minus 1. Remember, I told you that 1ab is the same as what? ab. Are you with me? Very good. So we are through with that. Thank you very much for staying tuned throughout the lesson, and I believe you are blessed by now. Have a wonderful day, and please do not forget to subscribe to our channel so that you can share, or you will be the first person to witness our video when anything like that pops up. Have it in mind that this is a channel where students are being helped throughout their mathematical challenges. Have it in mind that when you subscribe to this channel, you will be blessed always. Okay, now do not forget that your colleagues too are out there waiting for you to have a better conversation with them. Don't hesitate to share it among your friends so that your friends too will enjoy as you are also enjoying. Thank you very much for being with us throughout the lesson. God bless you. Bye bye.